All right, and we are recording. Hey folks, so this is a video where I will be going through the entire process of how I contribute to Kubernetes. So I'll be doing this by live coding everything that I am going to do for this particular Kubernetes enhancement proposal, uh, which deals with adding zero duration to the sleep action of the pre-stop hook of the container lifecycle. So we'll get into all of that. So I want to quickly like talk about why I am doing this and why, like, what I am planning to achieve out of this. So this is supposed to be like a log or like a documentation of all the work that I'm doing, and yeah, hopefully if someone finds this useful, they can use it as a reference to uh, like get started with contributing to Kubernetes. But this is basically my entire workflow of how I contribute to Kubernetes, how I build and run Kubernetes locally, and how I make changes to the code and so on. Yeah. Uh, so coming to our coming to our cap, this is what we'll be working on today, and in this particular video, what we'll be doing is this new feature to allow zero value for the sleep action of the container lifecycle hook. Uh, this was first shipped in 132. We are in the 133 release cycle right now, and the release cycle started in January of 2025, and the and Kubernetes 133 would be released by like sometime in April of 2025. So uh, we are past the enhancements freeze, which is the part of the so every release has a timeline, and the enhancements freeze is the first major deadline for contributors, where they have to get their features reviewed and like tracked for that particular release. And after the enhancements freeze, there is another deadline called the code freeze, before which all the code pairs has to be merged. So a Kubernetes enhancements proposal is like a design document or like an RFC for all the features that go into Kubernetes, and this is how the document looks like. And yeah, this is the KEP, or the Kubernetes enhancement proposal for uh, allowing zero sleep duration for the sleep action of pre-stop hook. So this has like a template where you have to answer a lot of like where you have to write down a lot of details, and there is a production readiness questionnaire which you have to answer, and folks from the community would review your answers and then give you feedback, and then validate the feature as ready to be tracked for the release and so on. So we have a bunch of stuff here. This is essentially the details of how this feature would be implemented and what we are trying to achieve with this. So I'm not going to read this entire cap in this video. I do plan to make such videos with a different cap that I'm working on, where I plan to go through the entire cap document. But since this feature is like very minimal, this should be an easy read if you're interested in like reading the cap. This is a good. I would say that this is a good cap to get started. Like this is a good first cap that you can get started reading. So essentially, what we are going to do is that we have the container lifecycle hook in Kubernetes. So whenever you are defining a container inside a pod, you can have like different container hooks. These are the hooks that are available right now are post start and pre stop. So if you add a pre stop hook to your container, it would execute that hook. It would execute that lifecycle hook before the container is stopped. And in the case of post start, it would be run before the container is like actually started. So these lifecycle hooks, post start and pre stop, can have different actions, and these are the three the lifecycle handler implementations that are there currently. You have an exec action with which you can like run a particular command inside the container before you actually start the process, or you can like make an http request to any particular url. Maybe this could be something like a health check to make sure that the like adjacent service is up or not, and things like that. And lastly, we have the sleep lifecycle hook. So what sleep does is the container would sleep for a specified amount of time before uh, like if you specify sleep lifecycle hook action inside post start, it would sleep for a particular amount of time before the container is started. And the case of pre-stop, the container would sleep for a specified amount of time before the container is actually stopped. So this can be useful for things like graceful shutdown and things like that. So the kep that we are working with right now, what it does is, as you can see here, that it says the sleep action is currently in beta. Uh, it says that the sleep action poses the container for a specified duration, and this is a beta level feature that is enabled by default using the pod lifecycle sleep action feature gate. So we will get into like I will talk about what feature gates are in a minute, but currently we have this sleep action for container lifecycle hooks. But as you can see here, like there is a note that says that the pod lifecycle sleep action allows zero feature gate allows you to set the sleep duration of 0 seconds. So which would essentially be a no operation. So this the original the pod lifecycle sleep action kept implemented the sleep action and implemented the logic to stop. So implemented the logic to execute the sleep from inside kubelet, but then the actual sleep logic did not allow a value of 0 seconds. So that was not like a valid that was not a valid duration of sleep that you could have for your containers. But once this feature was shipped, like some folks had created an issue asking if we are able to support sleep duration for 0 seconds, uh, so that we can essentially have a no op feature, like we can have like a no op operation before the container is stopped. So that's how this kept was conceived. And if you come to this particular link, so all the Kubernetes enhancements proposals are stored in a repo called Kubernetes/enhancements. And if you go to the issues here, there would be a corresponding issue for each kep. And the kep number is the number of the issue number that we get from GitHub. And yeah, the this particular kep is 4818. This is the kep which adds a zero. This is the kep that adds 0 as a valid duration for the sleep action. So if you come to this particular issue, you would be able to see the discussion link that like the discussion in the original kep, which started the which basically started off this kep. And you can see someone had asked like someone had a use case for having a 0 duration sleep before the container is stopped. And as of July 4th, 2024, this was not supported. Like you were not able to set a sleep of 0 with the original kep. So that was just how the validation for this particular kep had been coded. So it would have thrown an error saying invalid value 0, and the sleep must be greater than 0, or the greater than 0 and less than the termination grace period seconds, after which the pod would be killed by the kubelet. So this was the first the ask that started off this kep. So you can read this entire discussion if you're interested in that. And yeah, so this feature went as alpha in the 132 release. And in 133, which is the current release, I am trying to graduate this feature from alpha to beta. So what the difference between alpha and beta is that the feature would be turned on by default when it is graduated to beta. So it would still have a feature gate with which you are able to turn it off if you don't want to use it for some reason. But by default, when you run Kubernetes, the feature gate would be turned on and the feature would be available. So that is the graduation criteria for the beta stage. I will also come down to the cap where we define the graduation criteria. And yeah, in the alpha, so I'd like to talk about how uh, features are rolled out in Kubernetes. So we have like three different stages: uh, alpha, beta, and stable, where the feature would be generally available. And some caps would have multiple alpha releases and multiple beta releases based on how big the feature is and how many different moving parts the particular feature has. But since this is a very simple cap, we only have alpha, beta, and gamma. So alpha, beta, and like generally available or like stable stage. So in the alpha stage, the feature was implemented behind the feature flag. So what this means is that the code for the feature would be present in Kubernetes, but it would not be turned on by default. And you have to configure something known as a feature flag in order to like actually use the feature. So I can demo this in a minute. And in the beta release, the feature flag would still be there, but it would be turned on by default. In the case of alpha, the feature flag would be there and the feature would be turned off by default. So if you want to test out an alpha feature, you have to enable it like manually by yourself. And in the case of beta, it would be like all the features which are in the beta stage are turned on by default. And for generally available, the feature would be turned on by default and the feature flag would be removed. So the feature would be like a new default behavior of Kubernetes. So that is broadly how we roll out new features in Kubernetes. So I can walk through the code PR that was merged for this particular cap. So this was the PR that added the support for zero value. Uh, this particular PR only has a single commit. This is because I had to squish all the commits before merging the uh, PR. So I can go through essentially everything that was done here. So first of all, I added a new feature flag called pod lifecycle sleep action allow zero. So this is a feature flag that determines if the feature should be enabled or not. And I had to add this feature flag in a bunch of places. And we define things like log to default is false. So default value is false, and so the feature flag would not be turned on. And the stage is alpha, and this is in the 132 version. Log to default false. I'm not entirely sure what this is, but let us try to figure that out over the course of this like pair programming session, if you want to call this that. But yeah, basically I added a pod lifecycle sleep action allow zero feature flag, and I had to add this in a bunch of places. Uh, yeah, we need the feature flag to be in a couple of files, and that was added. After that, what I did was so essentially the sleep action was already there, and the sleep action already had a validation function. So this validate sleep action function would be called whenever you apply a pod spec which has all the relevant details for the containers that are created. And this particular function would check if the pod spec that we applied has a valid container lifecycle that uses sleep action based on whether the feature flag is turned on or not. So inside this validate sleep action function, we already have some logic, but what I there was some existing logic which would check if uh, the this is the validation for the existing behavior where the sleep of 0 second, like 0 seconds of duration was uh, not valid. So I moved this to an if else condition where if the allow pod lifecycle sleep action zero value feature flag is turned on, then we would have one validation logic, and if it is turned off, then we have a different validation logic. So if this feature flag is turned off, then what we would do is we essentially have these couple of lines that we have here, like this block of code is the same as what we have as the default behavior. So if the feature flag is turned off, then zero is not a valid value. Zero is not a valid sleep duration seconds. So we have the same logic here. But if the feature flag is turned on, like if the value of the feature flag is true, then there is a slight difference in the validation logic, in that the sleep dot seconds is validated where zero is where the validation counts zero as a valid value. So this particular condition becomes less than zero. So if the sleep is less than zero, then we throw an error saying that the sleep duration must be non-negative and less than termination grace period seconds. Either if it is under zero or if it is greater than the grace period. In the case where the feature flag is turned off, we default to the existing behavior where the sleep seconds must be greater than or greater than zero, and it cannot be a zero value. Or if the sleep is greater than the grace period seconds, then we also error out saying that the sleep needs to be less than the termination grace period seconds. So that is the that is all of the code change that we basically want for this particular cap to allow a zero value. Uh, but we do this based on the feature gate, and we had some more things to handle when it comes to the feature gate. One example of this is how we would set the feature gate in pods uh, so that version skew and upgrade and downgrade are handled. So let me go back to the skip again, and I will explain what I mean by this. So in the kept document, we have two sections called upgrade downgrade strategy and version skew strategy. So these are important because you need to have a solid plan for how you are planning to roll out the feature, so that if someone uses your feature in production and if they decide that they want to turn this off, Kubernetes should not break just because they turn the feature on and off again. And this would also your feature should also not break Kubernetes when people are upgrading their clusters. So if there is a version skew between multiple different components of Kubernetes, such as the API server and the kubelet, then all of those should be handled gracefully. And this these two sections in the kept document like makes you think about all the different edge cases that can happen, and you have to write down how you handle how you're planning to handle these. Yeah. So in the case of our cap, the upgrade downgrade strategy and the version skew strategy are pretty simple. So let's just go through these two sections now. So in the case of upgrade, if pre-stop sleep action, whatever existing behavior was there, that would not be broken. So if people had already created pods which have a non-zero value of sleep, that behavior would not be broken if they upgrade to a newer version and turn on the allow zero value feature gate. uh, in order to start using this, users would have to enable this feature gate manually, and once they do that, they can start creating pods where the sleep duration for the container is a zero value. And Once they do that, if they downgrade the API server, so API server is where the validation is happening. In the case of kubelet, the code which handles the sleep was using the go time dot after function. Oops. uh, yeah, the time dot after function was used by the original sleep action logic, and this already supports zero value, so we did not have to make any change to the kubelet, and all the changes that we had to make as part of this particular kep was only in the kube api server where we do the validation. uh, yeah, so if the kube api server is upgraded and folks start using the feature, and then if it is downgraded after that, they would not be able to create new pods where the sleep action has a zero duration, but existing resources which were created, this is the case, like if the kube api server is downgraded to a version where this feature does not exist at all, then uh, folks are not able to folks would not be able to create new resources, but existing resources which are there in the cluster which has a sleep duration of 0 seconds would continue to function, because uh, the pods have already been created, and kubelet is what takes care of the actual sleep logic. So 0 is still a valid duration for the time dot after function, as we just saw. And the existing pods would continue working. The same is the case for when the feature gate is initially turned on. And let's imagine a situation where you turn on the feature gate and you create a pod which has a sleep duration of 0 seconds, and then you turn off the feature gate. So in that case, you would not be able to create new pods which has a zero sleep duration, but the existing pods would still continue to work. So that particular logic of letting the pods which already have a zero sleep duration continue functioning had to be handled in the PR. So that's what I'm going to talk about now. So in the pod util file, uh, we have this function called get validation options from pod spec and meta. And inside here we have a struct, we have an options struct where we add bunch of different options for the feature gates and so on. And in the case of the allow pod lifecycle sleep action zero value feature gate, I added this as an option here. So I updated the struct where this is defined, which I should be able to show. Okay, what I'll do now is I'll try to open this file in the Kubernetes code base. Yep, I think this is a good font size. So I'll search for get pod. This method is called get validation options. So let me find that method. And yeah, so basically this options is a struct of pod validation options type. So if I open that, I can see that it has pod allow pod lifecycle sleep action zero value, and this is inside the validation.go file. So the validation.go file under package API score is where we define this struct. And let me find the file. Actually, let me get the line number. This is 4056. So this should be somewhere at the end of this file. Yeah, as you can see here, this is the place where I updated the struct, so that pod validation options has a new field, a new item for our new feature gate, which is allow pod lifecycle sleep action zero value, and this is a boolean which denotes whether or not the feature gate is turned on. And once I added that to the struct definition, I added allow pod lifecycle sleep action zero value to the options inside the get validation options from pod spec and meta function. And this the value for this particular option is set based on whether or not the feature gate is enabled. So this is the helper function that we use, util feature. So we can do util feature dot default feature gate dot enabled, and we can pass the feature gate. So this is how this util feature package is how you can like check if a particular feature gate is enabled from inside the Kubernetes code base. And as you can read from this particular review comment here, what we do is we first enable we first use this to set the feature the value of the flag, the value of the option, and later down inside the same function we override the value, and we check if either the feature gate is enabled or if the pod lifecycle sleep action zero value is already in use. So this would handle the case that we have defined in the upgrade downgrade strategy. So if you enable the feature gate, then you should allow pods to be created with a zero duration of sleep. And the other case where that would still be valid is when you have already created a pod which has a sleep of 0 seconds, and if you turn off the feature gate, or if you like disable the feature, then that particular pod should continue to function. And let's say that you have created a pod and you enable the zero duration. You create the pod with a sleep duration of 0 seconds, and then you turned off the feature gate. And now when you have to update this particular pod, and let's say you're changing some other field of the pod spec, the validation should not fail because the feature gate is turned off. So we don't want the validation to fail. Even if the feature gate is turned off, we don't want the validation to fail if the pod is already using the feature. So that is what basically this line does. So we have a new function called pod lifecycle sleep action zero value in use, which checks if the given pod spec already has a zero value, and if that feature is already in use, then we should continue like that particular pod spec should be should pass the validation, and we should not fail even if the feature gate is turned off. So that is what this particular function does. I will open it in the editor here. So this is the line where we are defining the initial value of the feature gate. Sorry, not this one. Sleep action zero value. So this is where we check if the feature gate is enabled or not, and then later down, if all pod spec is not nil, that means that like this block of code would only be executed if you are updating a pod. So if you're creating a pod, all pod spec would be nil, because you're creating the pod for the first time and you're not updating a existing pod spec. So in the case where you're updating an existing pod spec, where you're like updating an existing pod, we want to check if the pod already uses the sleep action with a zero duration. So that is why we update this options value again based on whether or not the pod uses the zero duration sleep. So we have this function here. So if I go to this the definition of this particular function, we can see what happens here. And it takes a pod spec and returns a boolean. So this boolean would represent whether or not this pod lifecycle sleep action zero value is in use or not. So if the pod that we give already uses the zero duration, we need it to be valid. So that is why we are returning whether or not this is in use, and we use that value, whatever we get from that function, to set the final value of the other port lifecycle sleep action zero value here. So if I search for this options dot allow port lifecycle sleep action zero value, this is like in this particular file it is only used in two places, but if I search for it here, I can see that this is what we use inside the validate sleep action function to actually decide whether or not zero is a valid sleep duration. And this is set from inside the pod util.go, where we uh, handle this logic. So essentially what happens is that if you are creating a new pod, we would check if the feature gate is enabled, and this particular validation logic would be based on whether or not the feature gate is enabled. And if you are updating an existing pod where the zero value is already in use, and if the feature gate is disabled, even that would go through, because we have that necessary logic there. And the options.allow pod lifecycle sleep action zero value feature gate, like this particular option variable, would be set to true if the pod already has that particular feature in use. So if the pod already has a zero sleep duration, then even then we would continue using this particular feature validation logic, which allows for zero value. So when you try to update the pod where you are using a zero value, it would not break. So that is essentially what we are describing in the version skew strategy and the upgrade downgrade strategy. So yeah. All right. So now coming back to this particular pod lifecycle sleep action zero value in use function, what happens here is we have a function called visit containers. So this is like a helper function which can be used to go through all the containers of a particular pod spec. So if you give a pod spec and if you pass all containers, so this takes pod spec and a container type. So this is what we are passing as all containers here. So the container type can define whether or not you want this particular logic to be executed against all the containers, or all the init containers, or all the non-init containers, and so on. And you can also define a visitor function, which is what we have here. So this is a function that we have defined, which has the logic of how of what boolean that we want to return from the pod lifecycle sleep action zero value in the use function. So what this basically does is, if the life cycle is nil, then it returns true. So it returns true because we want all right. So in this particular case, if we return true from inside the visit containers function, we would exit from the visit container. So what we are essentially doing is we are checking if like we are going through all the containers of a particular pod spec, and if the if the sleep duration is set to zero in any of the container, then we are valid. Then we want the pod spec to be valid. So we want to pass pod lifecycle sleep action zero value in use as true. So if the pod spec is nil, then we fail fast and return false. And if the life cycle is set to nil, the return true here is not this particular boolean that we are going to return. This essentially what happens is, if we return true from inside the visit containers function, then we exit out of the visit containers loop. So if the life cycle is nil for a particular pod spec, then that means that we don't need so we don't need to validate the pod based on whether or not the zero is set, the sleep action has a zero value or not, because if the life cycle itself is not set on a pod, then we can be sure that that particular pod does not use a sleep, like, it does not have a sleep action, and it does not have a zero value. So if we return true from inside the visit containers visitor function, then the visit containers loop would be finished, and the in use variable that we have defined here by default has a value of false, so we just return false. So if lifecycle is nil, then we are not using the zero duration, so we return false. And if lifecycle is not nil, and here when like in the next two if conditions, we actually check if both the pre-stop lifecycle is nil or not, and if it is not nil, then we check if we have a sleep action, and if sleep action is also not nil, we again check if the sleep second duration is equal to 0. So if it is equal to 0, then we set in use to true, and then we return false. So we exit out of the or in fact, I believe it is the other way around. I was mistaken. If we return true, then we break out of this loop for this particular container, and then we go to the next container. And if we return false, uh, we exit out of the entire loop, because if a single container uses a zero duration, then we can say that the entire pod spec needs to have this option set to true. So that's what we do here. We set in use to true, and then we return false, so that we exit out of the visit containers loop, and then we return in use, which is true, uh, because this pre-stop sleep seconds is equal to 0. Actually, we can look at the visit containers definition here. So if this is the visitor function being executed inside this code, and we are doing if not a visitor. So if visitor returns true, oops, I will try to open this in a different window so that we can look at the same code side by side. Yeah, we have the visit containers function on the left side, and let me open the other function. Yeah. So if the visitor function returns true, this particular expression would return true, and when we are negating it, we get false. So this won't happen. So return false would not happen, and then we would go to the next container in the pod spec. And if this returns false, if the visitor function returns false, then this expression returns false. When we negate that, the this entire if condition would equate to true, and since this entire expression equates to true, we actually return false, so we would exit out of this particular loop. So that is basically what happens here. So whatever I had explained initially was wrong, and whatever I had corrected myself with was the right logic. So if we return false here, then uh, we don't need to go through the rest of the containers, and we essentially exit out of this visit containers, like all the loops inside the visit containers. And this is the case for both init containers, regular containers, and ephemeral containers. Yeah, so at the end we return in use, and based on that we set the value, and the validation takes place uh, so that pods which have used the feature are also valid. All right. Uh, so that is most of the code changes that we have made for this particular feature, and all the other changes that you can see here in this PR are so that we passed down this options. So the initially the pod validation options was not used inside the sleep action function, validate sleep action function, and right now we have added pod validation options as a new parameter for this function, and we had to pass it down, and we had to pass down the pod validation options throughout all the different validation functions. So at the top level, so validate sleep action is used inside like there is like I believe I had written this down in the PR thread. Let me try to open that. Yeah, this is how the entire validation logic works. So at the top level, we have validate pod spec, which is what validates all the pod specs for both create and update, I believe. And inside this, we have both validate containers and validate init containers, both places where all of these functions are called. So we have validate lifecycle, which uh, validates the pod specs lifecycle section, which has both post start and pre stop hooks, as well as yeah, post start and pre stop hooks with either of these different hooks. And inside validate lifecycle, we have validate handler and validate sleep action, and we also have validate liveness probe, where like inside of validate probe, we have validate handler again. So validate handler again calls validate sleep action. So this needs to be one level to the right. Actually, let me just edit that. So if someone uses this in the future, they are not confused. Yeah. So validate handler calls validate sleep action, and validate handler is being called in a bunch of places. So I had to update all the different function parameters for uh, all these different functions, so that the so that me adding a uh, new parameter to the validate sleep action function does not break the entire thing. So yeah, that is essentially what happens in all of these lines. Yeah, I added a new port validation options to all the function uh, definitions so that the entire thing works. And yeah, that is essentially how the entire validation works. And I also added a bunch of test cases for validating whether or not so there are test cases where the feature gate is enabled, and we check if 0 is a valid value. We There are test cases where feature gate is disabled, and we check uh, we confirm that 0 is still invalid if the feature gate is disabled, and so on. So there are a bunch of test cases that I added for this particular validation function. And there was also an end-to-end test which would create a pod, and which would create a pod which has a sleep action uh, duration of 0 seconds, and then we kill the pod, and we make sure that the pod is killed in a valid time, and so on. So that is pretty much everything that I had done for the alpha release. Now, uh, for beta, the changes are even more minimal. I would need to I would need to update the feature gate. So I believe I would need to update it here so that uh, the pre-release version is updated to beta, and default value would be true, so that the feature would be enabled by default in beta in 133. And I also want to add a bunch of more test cases to make sure that the feature works as intended. And yeah, I guess if there are anything more that needs to be done, I would figure that out on the way. So yeah, this is what I have in mind. And as you can see, I have the Kubernetes code base cloned locally, where I am up to date with the master branch. So this is the latest code that we have. And oops, yeah. And as you can see here, we have all these different functions. So all the code that I walked through right now, we wouldn't need to make any changes there, but we would need to update the feature gate. So I would be going through how we update the feature gate, and how we make sure that the feature is enabled by default and so on. So first of all, I want to demo this feature in action. So what I will do is build Kubernetes. So I have a blog. So in my personal website, I have a section in my blog called Kubernetes development, and these are notes on how I these are notes on my Kubernetes development workflow, how I do things, how I build Kubernetes locally, and so on. And this is also the place where I'm planning to keep these videos. So I would probably upload these recordings to YouTube and add them as a post here. So this one would be titled something like uh, rolling out features in Kubernetes and how you uh, handle like feature graduation. Yeah. So the reason why I came here now was to open this building and running Kubernetes with kind article. So this post explains how you can compile Kubernetes from source locally. Yeah. So I'm going to be using this kind build node image command, and I'm passing the architecture as ARM64 because I'm running this from an M3 MacBook Pro. So the architecture of the M series chips is 64. So I need to pass that as a flag here so that the image is built for this particular architecture and Docker does not throw me an error. Docker does not start complaining when we start Kubernetes with kind later on. So I'll let this run for a couple of minutes. It usually takes a couple of minutes to compile the entire Kubernetes source code into into a node image which kind can use to create clusters. So while this is going on, I can explain my process of like building Kubernetes. So now when we have run this kind build node image command, what we are essentially doing is we take the entire source code that is present in this directory. So I'm running this from inside the Kubernetes repo directory in my machine, and this is building the code which is present locally. That is why we are passing this dot. This is basically the path to which the path to the Kubernetes code base from where we want to compile the binaries. So I'm running this from inside the same directory. So I'm passing dot as the current directory, and we build custom node images which we would be able to see if I run docker images. So you can see a bunch of images here, and you can also see kindest node. You can also see a bunch of images called kindest node. So kindest node latest is the Kubernetes binary that I had built, and the last one I built was 4 days ago. So now once this command finishes executing, you can see that kindest node would have the latest timestamp. And how we would go about testing our changes is so in this particular build of Kubernetes, the pod lifecycle sleep action allow zero value feature gate would be still in alpha because we have not made any changes to the code. So once this is done, what I am planning to do is yeah, I need to find the file where we made the change to the feature gate. So versioned feature list. Yeah. So in this particular file, if I search for sleep action, yeah, as you can see here, the original parent kept, which has the feature gate port lifecycle sleep action, was alpha in 129, and in 130 it graduated to beta. So I would add a similar I would add a similar section for the port lifecycle sleep action allow zero feature gate as well, so that it says it is in beta in 133. And with that, once we make the change, once we build the image, we should be able to run Kubernetes with that particular image, and we can confirm whether or not the feature is turned on by default. So what I'll do now is I'll pause the recording so that I can come back once the uh, image build has been completed. All right. It took 8 minutes and 33 seconds, but the image is compiled now. Usually it takes like this happens much quicker. I am not sure if having a video recording on the side is affecting the CPU performance. Uh, yeah, but now that the image is compiled, and if I run Docker images again, I can see that this node latest image was created about a minute ago. So this is the latest build of Kubernetes that we have. So what I'll do now is I already had a cluster running. So if I open my Docker dashboard, I can see that I have a bunch of kube build containers, which are the containers with which kind builds the node image like we just saw. And I also have a cron cluster. Let me increase the font size. Uh, yeah, I have a cluster which has single control plane node and six worker nodes. Yeah, six worker node cluster running. So let me first delete the cron cluster, and we can use the kind build node image that we created to create a new cluster. Right. Now that I've deleted the cluster, I will show you how I am going to create a new kind cluster. And for this, I will be using a kind cluster config. So a kind cluster config is basically a file where you can define how your cluster should be set up. So you can have different things like how many nodes you want in your cluster. So if you want to have like multiple control plane nodes, so you can maybe have like three control plane nodes for achieving quorum, and you can have like a worker node. You can have any number of worker nodes, and you can use this kind cluster config to set up different types of Kubernetes clusters to like test different things. Like one example is I have a kind cluster config. This is a regular cluster where the feature gate is turned on. So this is the pod lifecycle sleep action allow zero feature gate that is set to true. And this is done at the cluster level. So this will be turned on for all the different nodes. But if you want to set feature gates on specific nodes, you can do that. And this would be useful if you want to test features like version skew or like the upgrade, like all the different scenarios where you would be upgrading and downgrading your nodes and so on. So as you can see here, this is the first configuration that setting here is for the API server, and the second one is for kubelet. So you can have like different options set for different components of the different control plane components that are running on each node and so on. So yeah, the kind cluster config is a very powerful tool for you to like configure your Kubernetes cluster created with kind, so that you can like essentially with this you can simulate a lot of different real life scenarios, and this is especially useful when you want to test code. uh, like you can test your logic that you've written for the version skew or things like that. So here what I'll do is I'll set the pod lifecycle sleep action allow zero flag to true, and I would use this to create a cluster. So I'll actually I will open this in a different terminal. Yeah. So I will create a new kind cluster and I will pass cluster.yaml as the cluster config. So this would create a kind cluster. Basically, what kind does is it runs Kubernetes inside Docker. So for each node, it would create a Docker container. And if I open my Docker dashboard, I can see that in action. So these are all the kind, like the 2 hours ago one. The 2 hours ago, the kind build container that says 2 hours ago is uh, the one where we built the Kubernetes image earlier. And we can see that we have a container running called bleep cluster control plane, and it is running the kindest node latest image, and it just started 30 seconds ago. So if I do k get nodes right now, I can see that kind automatically created the cluster and updated the kubeconfig file for me, so I can start working with my cluster right away. So if I do kget pods, I cannot see any pods, but if I look at the pods across all the namespaces, I can see that there are like different pods related to kind and Kubernetes running on the cluster. So you have your kube API server, your controller manager scheduler, and so on. And in case you want to look at the kubelet logs, you can exec inside the node. I hope this is like visible. You can exec inside the node and you can do journal ctl, and you can look at the the container runtime logs, or you can look at the kubelet logs. So kubelet would be running as a systemd service inside the uh, Docker container. So this is how you would debug kubelet logs or the container runtime changes that you're making as part of your work. So that is how kind works at a very high level. Now, what I want to demonstrate in this is that I want to have a pod which has a life cycle. So I have this nginx pod, and under life cycle, this is a different cap that I'm working on. I'll create a separate video for this. I'm trying to add a new stop lifecycle, uh, stop signal lifecycle hook, similar to pre-stop and post-start. So that would be a different video of its own. But here I will add a pre-stop hook, and inside the pre-stop hook, I'll add a sleep action. And for sleep, I will add seconds. Let's try to create a pre-stop sleep action with invalid value so we can see how the validation goes. I will just quickly look at the sleep action. Right, that does not help us. Uh, I wanted to see an example of the sleep action. Yeah, I just wanted to see if this would be uppercase or not. Looks like it is uh, lowercase. Yeah, I was just checking if the auto complete works. So this is the pod that we have. Now what I'll do is I'll do k apply pod.yaml, and yeah, this now says that the value of -1 is invalid and the termination grace period seconds is 30. So let us try setting a value that is above 30. So if I say 32, if I try to apply the pod again it says invalid value 32. The value must be non-negative and less than the termination grace period seconds. So one interesting thing here is that you might notice that it says the value must be non-negative and not that the value must be greater than 0. So this is the, let me open the PR. Where did it go? Yeah, this is the change that we had made in the validation.go file. which we had gone through earlier. So this was the new message. So the message that says must the value must be non-negative and less than the termination grace period seconds. This is the error message from the new code that I had added, and this would only be shown if the feature gate is enabled. So this is something that we had done when we started the cluster. So in the cluster, we can see that the pod lifecycle sleep action allow zero feature gate is enabled. So that is the reason why we are given a message. That is the reason why we are given a message that says that the value must be non-negative. So what I'll do now is I will create a pod which has a sleep of 0, and if I apply it, I can see that the pod got created. If I do kget pods, I can see that the pod is getting created, and if I get the pod nginx, if I get the YAML for this pod, I can see that this nginx container would have a pre-stop lifecycle action, and it lifecycle hook, and it has a sleep action with seconds with a value of 0. So that works. So now what I'll do is I will delete this cluster. I will get rid of this. Actually, I'll just comment out the feature gate. So I'll do kind delete cluster. So we deleted the entire cluster now. And what I'll do now is I'll create the cluster again. The difference here is that, oops, yeah, I deleted the wrong cluster name. So this is supposed to be bleep cluster. Yeah, the the kind delete cluster output sort of tells you whether the cluster deletion was successful or not. Like if you see this line which says deleted nodes and then you see a list of all the containers, then that means that the cluster was deleted. In the earlier case, when I deleted the cluster, it just said deleting cluster, cron cluster, and it didn't actually list the nodes or the containers which were deleted. So this is how you can figure out whether or not the kind delete cluster operation was successful. So now that we've actually deleted the cluster, now I'll create the cluster again. And this time the feature gate, like I've not mentioned the feature gate at all. So this is akin to not having these two lines here at all. And once this cluster is up, let's see two things. The first thing is whether or not the validation error messages that we see, let us compare them with the validation that we saw here. So this one says must be non-negative. The value must be non-negative when the feature gate is turned on. So now if I get nodes, I can see the node is not ready yet. Okay, now it is ready. Now the pod.yaml has a sleep of 0. Now if I apply the pod, it fails, and it says invalid value 0 must be greater than the sleep duration must be greater than 0 and less than the termination grace period seconds. Enable allow pod lifecycle sleep action 0 value feature gate for 0 sleep. So we actually show this in the error message whenever the validation fails, that if you want so this error message would only happen if a user is trying to set a value of 0 when that is not allowed. So we sort of give them a pointer that you can set this feature gate to be able to do whatever you're trying to do right now. So this is the behavior of the sleep action 0 value kept in the alpha state. Now what we want to do is we want to have this turned on by default. So users do not have to pass the feature gate explicitly. Like if I want to disable it explicitly, I can say false and the feature would be turned off. But if I don't specify the feature gate explicitly, then the feature gate would be turned on by default, and we would mark it as a beta feature. So that is what we are trying to do. That is what we are trying to achieve for the pod lifecycle sleep action allow 0 feature gate in the beta release in 133. So let us actually write the code, and in the remainder of this recording, in the remainder of this video, we'll try to get that behavior up and running, and yeah, we'll figure out what all are the different changes that we need to make for this. I don't think I will write the test cases in this particular recording because it is getting a bit long, and this is the first time that I'm trying to do this. So I'll have like a different video for when I write the test cases. So let me look at the PR here and see where all I have added the feature gate. So package features cube features.go is a file where I've defined all the feature gates. So if I search for allow 0 here, I can see my feature gate mentioned here, and yeah, that is the only place. So we don't have any version information here, so we don't need to make any changes here, I believe. Yeah, the that was the first file. The second file was versioned cubefeatures.go. So we can see that we have a list of versions here. So let me open that file, and what I'll do is I'll compare the pod lifecycle sleep action allow 0. Boy, that is a mouthful to say every time. I'll compare this feature gate with what other feature gates have done. For example, we can look at what pod lifecycle sleep action has done. So looks like we need to add one more line here. So what I'll do is I'll copy paste this, and looks like I can just edit this to 133. Default is true, so we want it to be on by default, and I'll change the pre-release to beta. So you can see, you can compare other feature gates, the other existing feature gates, and you can see that all the features, whenever they're graduated to beta, they are enabled by default. So that is the behavior that we want here as well. So I added this line here, and the third file that I had edited in my original PR test e2e feature.go, I don't think we would need to uh, change that right now, because this is just defining the feature gate in the end-to-end test helper. I don't think I need to edit that right now, but I think the other, yeah, the other file that I see, the version feature list, also comes under test. But yeah, I don't think I need this if I don't have any tests running. So I'm not going to run the tests in this particular recording. So let's see if with just these two changes, actually just this single change, let's see if we are able to get the behavior. So the end behavior, the end goal that we have here is that we want this cluster config. Like if we create a new kind cluster with this particular cluster config, we should be able to apply this pod spec and be able to create the pod with a sleep of 0 seconds, because the feature gate should be turned on by default. That is what we want. So what I'll do now is I will build Kubernetes again with kind build node image. This is a bit faster now, I feel like, because I already have like a cache of the build. Earlier I did not have that, probably that might be why it took longer. So yeah, looks like it is going fast, even though I have like OBS running on the background. So yeah, let's see, let's wait and see how this goes. Yeah, if this ends up being the only change that we need to make in order to bump this feature from alpha to beta, then this would be one of those cases where there are like no code changes, and you only need to do like the graduation, like the feature gate graduation, and yeah, that would be all the work that we'd need to do, apart from the tests. Of course, we need to write proper tests and make sure that nothing is breaking, like none of the existing behavior is broken, or like uh, yeah, nothing is out of the ordinary. Yeah, this seems to be going fast now. So earlier the first build took 8 minutes and 33 seconds. I don't think this would take long. This is almost done. So let's kind of compare what the time difference is when we have a cache of the Kubernetes build available. Yeah. Now that we have some time and I'm curious about yeah, I almost thought my computer was hanging there for a bit. So yeah, I'll go to the original cap, which is the sleep action pre-stop hook, and I want to see what all they had done for the beta graduation, and I can see that the PR just says graduate pod lifecycle sleep action to beta, and yeah, let's see what all is done here. So there is only a single commit, which is probably squashed commit. They might have like more file changes inside. So kubefeatures.go, this was this the file that we changed? No, cube version cube features was the one that we changed. Okay, so they do change kubefeatures.go to reflect the latest changes. So I did not do that here. So let me try. Yeah, okay, that does not seem to be the right kubefeatures.go, or is it? Let me see. Yeah, I seem to be in the same file, but I think this was refactored. Like whatever we see here was refactored. That is why, like even if I search for pod lifecycle sleep action, I can only see these occurrences because the change that we see here was refactored. That was why we did not need to make that change. So whatever code change that we made should still work. Okay. Uh, yeah, we have the build, the node image built, and yeah, like a quick look at the PR for the beta graduation for the original parent cap for the sleep action. I can see that apart from the feature gate flip to be on by default, there is some refactoring here, and refactoring here in the util pod util file, and there are a bunch of new tests. Uh, the kept added metrics for how many number of times the sleep handler got terminated before it finishes. Yeah, all of these are requirements which were needed for the beta release, like adding metrics and all of that, and then yeah, more tests. Yeah, so that is pretty much that, like from a quick look, that is pretty much all the changes I believe, but this does look like something else, like a helper function or something. But yeah, I think it is used by the tests. So these all these changes are related to the tests. All right. So now that we have the new image, what I will do is I'll delete the kind cluster again. Uh, so this was the older image with the feature gate turned off. So now what I'll do is I'll create the cluster again from scratch, and the difference here is that we have this line of code. So since we are running a kind build node image from inside the directory, and if I do git status here, I can see that this particular file has been changed. So essentially the new cluster would have the feature gate turned on by default, which is what I expect to happen. But if this doesn't work, then that means that we need to update the feature gate in some other place as well. Let's see. So I can see that the node is ready. So what I'll do is I'll try something else before I try to apply the pod. So let me try describing the pod for the Cube API server. We should be able to see the Cube API server flags. So if we had set the feature gate, then that would have shown up here. But since this uh, cluster does not have any feature gates like explicitly mentioned, that information is not here. But I believe if I get the logs, oops, that's not what I meant to do. uh, I believe if I get the logs for the Cube API server, uh, okay, Looks like the API server logs also does not have the feature flags. I thought that we might be able to see something, but since we've not set any feature flags explicitly, I don't think it shows up here. So let's just try to apply the pod, and there you go. The pod got created. So now if I get the Nginx pod, I can see that the pre-stop action with the pre-stop lifecycle hook with the sleep action is set properly, and the value of the seconds, the duration is 0. So just with this line change, where we say that for 133 this particular feature gate should be beta, and it should be turned on by default. Just by making that one line change, we are able to run a cluster without setting the feature gate explicitly, and we are able to use the feature. So yeah, that's all it takes to graduate a feature from alpha to beta, I guess. In this particular case, of course, where we don't have any other changes, and all the code, like all the essential code changes that are required as part of the feature, are already merged to the Kubernetes code base. So this brings us to the end of whatever I had in mind, like the agenda for this particular video. So what I do now is I'll conclude this video, and I'll stop here. And in a future video, I will try writing test cases for this particular feature now that it is turned on by default. uh, I don't believe, like, I don't think I need to make any changes to the util.go file where we are using this allow zero feature gate, but because essentially the only change in beta is that the feature gate would be turned on by default, but the feature gate is still there. So now if I'm thinking of graduating this feature to GA from beta, I would need to get rid of the entire logic for processing the feature gate, because we are assuming that the feature would be like there by default in in the Kubernetes code base. So users would be able to use this feature without having to turn on a feature gate. So I'd need to get rid of this logic. I would need to uh, in the validation.go file, in package API core, yeah, essentially this particular if condition would be removed, and we would only have a single uh, validation where we check if sleep dot seconds is less than or equal to less than 0, sorry, not less than or equal to, just less than 0. So this would be the so after the GA graduation, this would be the only code that we have inside validate sleep action. So until the feature gate is there in the code, we still need to do this. But when we go from beta to GA, we would get rid of the feature gate, and we would simplify this logic like this. Yeah, that is pretty much everything that I had to do. I hope that this video recording was useful to you. Uh, I hope that you were able to get something out of it, in the sense that you were able to like learn how my Kubernetes workflow looks like, and how I work with things like feature gates, and how I compile my changes locally, and how I like quickly spin up and spin down clusters using kind based on the node images that I've created. Yeah, that is pretty much it. So this was kind of an experiment. I wanted to try if I can document my workflow with these videos, and yeah, I hope to do more of these. Do let me know if you have any feedback. Yeah, that's all for today. Thanks.